Today we're going to look at how we determine the atomic weights of different elements. Okay, if we look here at this particular slide, what we'll find is that whenever we represent an element, there are pretty much three things that we'll see associated with it. We'll see the atomic mass, which is the atomic mass is going to be equal to the number of protons and neutrons as found in the element. We're going to see the atomic number, and we're going to see here C, the charge. This element X is the symbol that we use to represent a particular element. Whenever we have the atomic number is going to tell us the number of protons. And because we know the atomic mass, we can determine the number of neutrons indirectly. So if the atomic mass is equal to the number of protons and neutrons, we simply can subtract the two numbers to get, meaning the mass number and the protons, to get the number of neutrons. So let's take a look at a problem. Here it says calculate the number of protons, neutrons, and electrons in each of the following. So we have boron, which has an atomic mass of 11 and has 5 protons. So in order to do this particular thing here, if the number of protons for this element is going to be equal to 5, the number of electrons for this element is going to be equal to 5, and the number of neutrons for this element is going to be the atomic mass minus the atomic number, which is 11 minus 5 is going to equal to a total of 6. So that there would be the number of protons, electrons, and neutrons for boron. If we look at iron, the number of protons is going to be equal to 26 because it tells us here with the atomic number. The number of new electrons is going to be 26. Whenever you have a neutral atom, the number of electrons and the protons are always going to be equal to the same. And then the number of neutrons in this particular atom will be 55 minus 26, which is going to give us 29. Okay, let's look at something a little bit more complicated. Right, here we have charge elements. So what makes these things charged is that it had to either lose or gain electrons. So if it lost or gained electrons, that means that the electron number is going to be different each time. The electron number is going to be different each time. It's not neutral, as we've seen before with the previous example. All the elements was neutral. So because they were neutral, we had the same number of protons and electrons. So let's look at potassium. The number of protons in potassium should be 19 because that's what the atomic number tells us. The number of electrons, however, is going to be 19 minus 1. The 1 because we have a plus 1 here, which means we're going to have 18 electrons, and the number of neutrons is simply going to be the atomic number 39 minus 19, which is going to give us 20. So again, the number of electrons is 19 minus 1. We lost an electron. So because we lost an electron, the atom now has an overall charge of plus 1. Let's look at sulfur. Sulfur, the number of protons here is going to be equal to 16. The number of electrons here is going to be equal to 16 in this instance plus 2, which gives us a total of 18, and the number of neutrons is going to equal to 16. So here, the electrons, it gained 2 electrons. That's why the overall charge of the atom is -2. So the number of electrons that it has is going to be 18 as opposed to 16 if it was a neutral atom. Let's take a look at magnesium. The number of protons we're going to have here is 12. The number of electrons is going to be 12 minus 2, which is going to give us 10. And the number of neutrons is going to be 24 minus 12, which is going to be 12. So again, here with the electrons, the overall charge of the molecule is +2, which means it lost 2 electrons. So because it lost 2 electrons, the total number of electrons is going to be 10. Okay, let's look at something a little bit more complicated.